didn't really get a chance to look at the issue. Huh? Wasn't there something green here? I inherently fixed it, apparently. I'm not gonna complain. I don't know how I fixed it. I genuinely do not know how I fixed it. Just double check that every single bone has a double constraint. So I didn't do any of the spine, okay. That's all. I did everything else. I don't know how that red thing vanished. Where was the setting I turned off last time? It was here. No. Come on, you can remember this. I think it was here actually. Somewhere. There. Ooh. Ooh, ooh, ooh. There's no such thing as an IK spine. Shift C, copy, transforms. No, I don't like it when it does that. Ah, okay. They're not connected at all. Wait. Fuck, I'm bored. Just double check that. Spine 5. I already did this. Oh. I just didn't do these. I think my issue was because it's not connected. Edit mode. Relations. So this is Congratulations. This connected, not. Mm-mm. I keep forgetting what's the prompt to connect / join bones. Yeah, you don't want to do that. Connect. Okay. Do I need this? Yes, I do. Wait. What if I... Uh-oh. Okay. Doesn't work like that. Okay. Oh, I need to get some tissue. Okay. The reason I didn't stream the other days is because of my exams again. I think I said that at some point. You know what actually I should do? I did this with the other bones. Whoa. That's the one. Shift S. Cursor. What's cursor to grid? Nothing. I think it gets bigger whenever you. Selection tool. Cursor. Just to make it as accurate. Hip R. Shift S. Control P. No. What if I like flip this? I see. Wait, that's not doing anything. Oh, it's because Let me just quickly. Control Shift C. Oops. Huh. Shift S. Why does it do that? I think it's because it's not connected or something. Control P connected. Not what I want to do. What I want to do. Wait. No. Let's just try it. Success comes from attempt. Shift C. Oops, Control Shift C. Transform. Yeah, it still does that. What the fuck is this? That's not right. We're back. I didn't figure out what the hell was the issue there. Okay, let me try. Copy transforms. Yeah. Alt G S R. None of that works. Okay, Control S. Twice, 3, 4, 5. I'm gonna close Blender. I'm gonna relaunch it. Hang on a moment, okay. Okay. Still there. Still red as fuck. Okay. Why does this happen? Amateur 1. Spine bottom 1. And that seems perfectly normal. There's still a red dot there for no reason. Hips L, hips R. Let's try that. And it's perfectly fine. What? Wait. L R. Nope. No, something is wrong. This is 2. We don't need 2. What? Oh, there you go. I had a hip R. Oh no, I'm have to go into weight painting. That's not supposed to happen. Oh, I hate this. See that? There's a tiny bit of color. I hate this. Ah. Just loves doing that. Oops. Oh my god. all the way up there. I don't give a fuck anymore. Yeah. I'm thinking, do I make this? Yeah, that's how it works. You make this your control rig. Start with FK first, then. What was this one for again? I don't remember. I don't think I'm gonna use this. It's just to move everything, and everything is moving, so no issues. Do you know what? I don't want to do. I don't want to do, what do you call it? Fuck. Modeling anymore. Not modeling, sorry, rigging. So, okay, I can just select armature there. So, what I want to do is materials. I can definitely model this better. That's something I will point out. But that's something that I'm not gonna do today. Doesn't matter, no one's gonna see that. Actually, I'm not in the North Pole any longer. I thought I'd fix it, but whatever. If I go quiet and I'm not doing anything, it's because I'm working with my phone. Shading. Active. Was it not texture paint? No, that's different. Don't die. Oh no. No, this is not. Oh, okay, there you go. It just took a while. I made you quickly Control S, so okay. Thanks for. Why is that showing up again? I thought I said no extras. I like the way the image used here at the bottom right is a fucking outside park. Let's do visor first, it'll be the most interesting. New. Fuck. Yo, I've never done this before, I'm gonna get cooked. Fuck me. I wanna name it. Visor, I guess? Why not? I remember something here where oh no, line style. Oh right, the fucking plugins. Oh, I forgot about all the plugins. It's alright. It's alright. Best to learn how to walk before you run. Wasted, losing, for I lose my mind. That was so retarded. I'm gonna lock in. You're not gonna hear me talk for a bit, but this does mean I'm gonna be. Actually, let me clear my desk space first. So much unnecessary shit. So I'm gonna be quiet basically. You won't be hearing me talk. But this is kind of. That means I'm gonna learn the most, hopefully. Wish me luck. Oh Lord. Give me strength. Instantly set to PBR.
So you got some PBR textures, but manually setting them up takes.
Any day now.
With some clever node placement, it's easy to get some really cool effects using Blender's shader system. So I looked around and I realized that no one has made a video on this yet, maybe for a good reason. I realized that something like this might not get a lot of views, but I just decided someone had to do it. So I decided to take one for the team real quick and present to you all of the Blender material nodes explained as quickly as possible. I'm not sure how long this video is going to end up being, but it's going to be a good resource for you to just browse through. You can look in the description for links to the various node categories. Do keep in mind that this is going to be an overview of each of the nodes. I'm not going to be explaining each and every input parameter and output there is for each node. If you would like some more detailed descriptions of each node, I will be linking you the Blender documentation for the shader nodes in the description, as well as various other resources that will be mentioned throughout the video. And also keep in mind that this is going to be a little less of a humorous video. I wanted to specifically make this a resource that clarifies some of what the documentation says. So with that, please enjoy this resource. It took a stupid amount of time to make, so as always, a subscription or like is much appreciated. But all I can ask beyond that is that you take a look at some of my other content as well. Enjoy, everybody. The ambient occlusion node takes whatever ambient occlusion is being generated on the model and returns it either as color or black and white data. That means in cycles it should be working automatically, but in Eevee you're going to need to check the ambient occlusion box in the render properties settings for it to start. Samples control the resolution, inside basically treats it as if the model is inside out, only local means other objects won't affect the ambient occlusion, color gives it a tint, distance controls how far away other objects can be to be considered for occlusion, and the normal input allows you to use a normal map that will also be included in the ambient occlusion. The attribute node is a testing node that allows developers to use attributes of models that they haven't created a node for yet. Most of these attributes actually do have nodes now, but you can use it to input things such as normals, vertex colors, and UV maps just by typing in the name and output that as a color, vector, or black and white data. The camera data node returns data based on the camera, as you might expect. The view vector node shows your data based on the model relative to the camera's position. The view z depth displays a linear gradient based on how far away the camera is from that part of the object, and the view distance does the same thing except with a radial gradient instead. Fresnel is an algorithm that determines where light should be reflected and where it should be refracted off of an object. In my experience, it's most commonly used to mix two materials, and it can be used to great effect, as you can see here. Next is the geometry node. This one is a beast. The first output gives you the actual position of an object. The normal output will give you the normals of the object in world space, not local space. That's the difference. True normal is just like the normal output, except if your object is flat, it's still going to show that even if you've shaded your model smoothly. So back facing returns black for the backside of a face and white for the inside. Hair info does exactly what you might expect. It can tell you whether something is a strand, where the ray intercepts with the strand, the thickness of the strand, and even return a random value to maybe randomize the hair color and things like that. The layer weight node is similar to the Fresnel node, except it has a few more options. To start, we also have this facing output that is similar to Fresnel, except it has a more linear fall off. Additionally, it's much easier to work with when you're using a 0 to 1 scale instead of the alternative. If you're into tricking the renderer, the light path node is for you. Starting with the is camera ray, this will show you if what you're looking at is a direct view of the camera or a result of a reflection from another object. And this could be useful, let's say you wanted to remove extra detail from the reflections in your scene to save you some render time. Well, that's what you would use. Shadow ray does something similar for shadows, diffuse does something similar for diffuse, glossy. This one is singular ray, actually has to do with how sharp the glossy will be. Reflection is pretty much what you would expect. In this case, it's actually going to be the exact opposite of the is camera ray. It will show you when something is the result of a reflection or if it's a direct view of the camera. Is transmission ray does the same thing with transmission. The ray length returns data based on how far light travels between each bounce. So if I pair that with a transmission, you'll see that it Now that we've got that out of the way, let's talk about all of the different shader nodes. The first is add shader. Essentially, it's going to just add any shader data on top of any other shader data.
What?
Add shader. Essentially, out of the way, let's talk about all of
I don't have all those options. Never mind.
the different shader nodes. The first is add shader. Essentially, it's going to just add any shader data on top of any other shader data. For example, if you add a diffuse and a glossy together, you could get a nice porcelain or ceramic material. We've talked about the anisotropic BSDF before when we talked about the tangent input. I think the best way to think about what this shader does is to think of the bottom of a kitchen pan. It's one of the only places I've seen this kind of effect going on, but it's a great way to bend the light around a certain point. Now, this is the diffuse BSDF. This used to be the default shader for Blender materials. And so now I think it's a good time to discuss what exactly a BSDF is. It's called a bidirectional scattering distribution function, and essentially what it's meant to do is calculate how light rays should interact with the surface. The diffuse BSDF does it much differently than something like a principled BSDF. This is now the default for Blender, but we'll get into that a little later. In the diffuse BSDF, we have a color input, a roughness input, and a normal input. The color, as you might expect, adjusts the color of the surface. The roughness adjusts how precisely light rays should be reflected off of the surface. And the normal input allows you to use something like a normal map. For most practical uses, the emission shader turns any surface into an emissive surface. You can use a color input to change the color or maybe make it some sort of texture, or you can use the strength to adjust how strong the emitted light should be. The glass shader also works how you might expect, turning your object into glass. The first parameter is the distribution function. These are the same options that you have with the glossy BSDF. Most users will not have to worry about these. Next, you have a roughness input, and this determines the sharpness of the refraction. Imagine it like this. If there's a sun or a light ray coming into the glass like this, with a roughness of 0, it's going to hit the surface and then bounce straight through. However, if the roughness is something like 1, it's going to hit the surface and then scatter throughout. That's kind of how you can imagine roughness. And as you can see, this is the result of all of that light scattering. The IOR is something that we call index of refraction. You see this option in a Fresnel node as well. It tells the light at what angle it should pass through. For instance, if you have an IOR of exactly 1, it will be pretty much a perfectly clear object because the rays are literally passing right through. The default is 1.45, but you can adjust this if for whatever reason you felt the need to. The hair BSDF is what most people used to use for hair simulations. You can of course adjust the color and all of that, however it has most recently been nearly replaced by the principled hair BSDF, similarly to how the diffuse BSDF is now to the principled BSDF. The holdout node is something that you don't hear talked about a lot. What if I told you that there's a Suzanne that is visible in this scene? Yeah, it's not visible. You can only see it if you turn the scene like this. That's right. What the holdout shader does is turn the object into what is essentially an alpha mask. So you could mask out other objects. You could do really whatever you want with this, and to make sure that it works, turn the film to transparent and the render properties, and that's pretty much what most people will use this for. The mix shader is used to mix two different shaders together. You've got this slider, which will determine which shader has more effect over the other. As you slide it towards the left, it will use the top shader more. As you slide it towards the right, it will use the bottom shader more. You can, of course, control this with any type of black and white data. One of my favorites is the Fresnel input node. If we plug that into a viewer, we can see exactly what that data looks like. And now you know about what IOR is, so you can change that to whatever's appropriate for your scene. The principled BSDF node is truly a gift. There are so many different options, it's almost impossible to talk about them all in detail without going far over time. As you might imagine, the base color is again the color of the surface. The substrate
Mine looks different. Whoa. Uh-oh. Uh-oh. Oh shit. Oh, what did I do? What did I do?
Surface has to do with subsurface scattering, which we will explain later as it has its own node actually. The metallic will adjust the metalness of the surface. Usually though, this should be 0 or 1, and you'll see if you use a metallic texture that those are usually very polar black and white. For the average user, specular means how much reflection is possible. For example, if I took the roughness all the way down but the specular is at 0, we're still not going to see any reflections. However, once I turn the specular up, now we can see all those nice reflections. Roughness works similarly to how it does.
Like, I don't really have that.
Literally everywhere else. If you turn it down, the surface will be less rough and provide sharper light reflections, and conversely, when you turn it up, it will scatter more light, reducing the sharpness of the reflections. We've
You know
talked about it in this.
I'm just gonna end it here. I really feel shit today. I'll probably, I don't know. I'll probably do this in my free time later, but not on stream. But there's nothing I really can do on stream. I already did everything that I knew.